everyone, I'm Won-Lee. I'm going to explain about two-way ANOVA with replications. Section 9, there was two-way ANOVA without replications. Without replications means there is only one observations for each treatment. But here, there are several observations for each treatment. So without replication case will be applied to medical data or some lab data because it costs a lot for obtaining observation. But here, with replication, is for social science data. Okay, there are multiple observations for each treatment. Let's see what is the difference here. Okay, having replications means there are multiple observations. Here, it is assumed that it is possible to have R observations, R many observations for each treatment. They are P, Q treatment. The possible observations can be obtained as shown in the following table. So I use three subscript IJK. Data 111 is what? A1, B1, and first sample. Second sample, R's sample. That is Y111, 112, 11R. Here, 1, 2, 1, 1, 2, 2, 1, 2, R, and so on. Okay? You understand the structure of sample? Then, the model will be mu plus alpha I, beta j plus alpha beta. It's not a product, it is a notation. Say interaction effect. Ij plus epsilon ijk. This is error terms. I from 1 to P, 1 to P, J from 1 to Q, K from 1 to R. You understand this model? It is not that difficult. Assumption is same. Epsilon ijk follows normal distribution with a mean zero variance sigma square. And we can test three hypotheses. First one, alpha 1, alpha p equal to 0, no treatment effect. And beta 1, beta q equal to 0, no treatment effect of factor B. And alpha beta ij equal to 0, no interaction effect. This one is called interaction effect. Do you know what interaction effect is? Okay, I'm going to explain interaction effect later, not now. Okay, then the equation obtained through the sample for two-way ANOVA model with replication is, it is just the same. Yij, mu. What is mu? Grand mean. So the estimator, I use capital letter, so I call estimator, is y dot dot dot. Y dot 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 is what? Mean of all the sample. How many? P, Q, R, many samples there. So y dot 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 is mean of all samples. That is estimator of mu. Alpha I is ith level effect, treatment effect of factor A, right? So y dot dot y, sorry, this one, i's, y dot dot is mean of ith treatment of factor A. So y dot dot minus y dot 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 is the estimator of alpha I. Beta j, the estimator is like this. Y dot j dot here, this one is mean of these samples minus y dot 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 plus. It is some complicated and I want to left for a while. Okay, what is error terms? In this case, the samples here, right? So there are many observations and the sample mean of these R observations is y11 dot. Okay, it is a sample means y 1 dot. So each observation minus mean, its means, y11 dot is going to be error, residual in this case. Yijk minus yij dot is residual, realized value of error. Then for equality, we arrange both aside yijk here. Okay, that's okay. But we have to erase y I dot dot yi dot dot here first. This one erased with this yij dot minus yi dot dot. I missed the dot here notation. Dot 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 3 dot. And this one cancel out. This one is cancelled out, and y dot 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 minus plus. Okay, so that what interaction effect will be expressed like this. It is a little complicated than before. And what? Move this y dot 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 to the left side and square them, and what? Summation for ijk. Summation ijk, this one, this part squared, this part, second part squared, and summation ijk, and interaction term squared, summation ijk, and the last residual term squared, and summation for ijk. And the cross product, okay, cross product term, triple summation, all the cross product terms gonna be zero, disappear. See, it's simple. Total sum of square of a factor A, sum of square factor B, sum of square interaction term AB, and sum of square residual sum of square. Okay, see again here. Okay, total sum of square, SSA, SSB, SSAB, SS, this one is SSE. Degrees of freedom, they are what? PQR, many, these terms, square terms, then degrees of freedom will be PQR minus 1, because y dot 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 is mean of all ijk's. Understand that? They are how many terms here? P many terms, I from 1 to P. So degrees of freedom is P minus 1, here Q minus 1, here P minus 1, Q minus 1. It is pretty hard. It's, I think some complicated thing. So now see here, residual sum of square. Okay, let's see again this table. They are what? R minus 1 degrees of freedom, right? R minus 1 degrees of freedom for all PQ treatment. So PQ times R minus 1 is the degrees of freedom for SSE. Understand that? Then for equality, the degrees of freedom should be P minus 1, Q minus 1. PQ minus P minus Q plus 1. So equality holds. PQ, this one is PQR minus PQ. So PQ cancel out, P out, Q out. Okay, PQR here minus 1, and minus 1 out, and minus 1 left. Anyway, okay, equality holds. So when we have sum of squares and the what degrees of freedom, we make ANOVA table. ANOVA table is like this: associate, sum of square, degree of freedom, mean squares, F value. SSA, the calculated value of this will be here, and SSB, SSAB, SSE, residual sum of square, will be calculated this time, and will show up here. And the degree of freedom, okay, and sum of square divided by degrees of freedom is mean squares B, mean squares AB, MSE. MSE is what? Is the real variance of estimate. estimate in this case. The computer will provide ANOVA table like this. So some value is estimate of sigma square. Understand that? And the F value for hypothesis test, null hypothesis here, alpha 1 up to alpha p equal to 0. The p is the value of a tested statistic for this hypothesis is here, and the p value printed out here, three hypotheses. So I tried to explain the background of ANOVA, two-way ANOVA with replications, but you don't have to memorize anything here, but you better understand how going on, okay? I recommend you to understand the logic and the base of ANOVA model. That's enough, I think. I'm going to explain interaction effect next time. Okay, that's it today. Thank you. Bye.